Hello everyone, welcome to my channel SGKM Education. This channel is for the preparation of chemistry for JEE Mains, Advanced and NEET level exams and any other competitive level exams. And also we shall discuss about the different job notifications related to chemistry and any other news. So first we shall discuss about the spin only magnetic moment. This is the very important topic which is coming in previous years exam different competitive level exams like JEE Advanced Mains level, NEET level. So what is spin only magnetic moment? So spin only magnetic moment is the magnetic moment value which is represented as mu, that is equal to root over of n into n plus 2 bm. So what is n here? N is the number of unpaired electrons. Which electrons? Unpaired d orbital electrons. Okay, for d orbital only. So this is actually the topic from coordination chemistry and other inorganic compounds also, because this question if you see they are asking about only manganese oxide, titanium oxide and vanadium oxide. So this is not a coordination complex, is normal oxide compounds. So these all are the transition in metal, uh, because manganese, titanium, vanadium, all are the transition metal. Now how to calculate? First read the question carefully. They asked about the strongest oxidizing power among this compound. So that means from these three, manganese oxide, titanium oxide, and vanadium oxide, which on is the strongest oxidizing power? Or which one is having strongest oxidizing power? So first, how to calculate oxidizing power or oxidizing agent strongest? The number of oxidation number or oxidation state is increases means oxidizing power also increases. So you just find out the oxidation state of each compound, that is manganese oxide, titanium oxide and vanadium oxide. So first calculate manganese oxide. There are two manganese atoms, so 2x plus 3 of 3 into minus 2 equal to 0. So why minus 2? Because oxidation state of oxygen is minus 2 generally in case of oxide. So 2x equal to plus 6, x equal to plus 3. So what is the oxidation state of manganese? That is plus 3. Now for titanium oxide, only one titanium atom, so x or minus 2 equal to 0. So x equal to plus 2. Therefore, oxidation number of titanium is plus 2. Similarly, for vanadium oxide, x plus or minus 2 equal to 0. So that is also plus 2. So vanadium also plus 2. So plus 3 plus 2 plus 2. Which one is the strongest oxidizing agent? That is manganese, because manganese is having plus 3. So we have to find out only the Bohr magnetic value or spin only magnetic moment value of manganese oxide. So let's see. First, for manganese oxide Mn2O3, what is the normal oxidation atomic number of manganese? That is 25. So according to 25, electronic configuration would be air, that is argon, 18 electron system, 3d5 4s2. So 18 plus 5 23 plus 2 25. So that is atomic number. Now here manganese in plus 3 oxygen state. So Mn plus 3 is what? What is the electronic configuration of Mn plus 3? Air 3d5 4s2. So now 3 electrons will come out from the outermost shell. So 2 electrons will come out from 4s orbital first, then 1 electron from 3d. So now 3d is become 3d becomes 3d4. So 3d4 means there are 5 d orbitals. So there are only 4 electrons. So 3d4 means 4 unpaired electrons here. Okay, 4 unpaired electrons. Now you calculate mu value. root over of n into n plus 2, that is root over of 4 into 4 plus 2, or root over of 24 bm. So almost 4.92 Bohr magneton, and they are asking about integer, that is nearest integer. So nearest integer means if you are getting 4.92, that is approximately 5. So 5 is the answer, 5 Bohr magneton. Okay. So now we'll go to the second question. So this is the second question basically. The calculated spin only magnetic moment of this compound. Okay. Which compounds? K3FeO6 OH6 and K4FeOH6. So this is basically coordination complex. Okay. So first, what is the transition metal here? Iron. Okay. So K3 first, whatever it is, you have to find out the oxidation state first. So K3FeOH6. So K3 is plus 3, potassium plus 1. So 3 of potassium is plus 3, and outer, that is anionic complex. FeO is 6, 3 minus. Now, from here you can find out the oxidation state of iron. A iron on atom, so X plus 6 into minus 1, 6 OH. OH is basically minus 1 hydroxyl ion. That is equal to minus 3. So we are just finding out from this portion, this coordination sphere. Okay. So X plus 6 into minus 1 equal to minus 3. So therefore, X equal to 6 minus 3 plus 3. So iron is here plus 3. So first compound, iron is plus 3, Fe3 plus. Okay. For second compound, similarly you have to find out K4FeOH6. So minus 1 of OH. So K4 means first 4 into plus 1 plus 4. So coordination sphere is minus 4. Anionic complex is minus 4. So now X plus of 6 into minus 1 equal to minus 4. So X equal to 6 minus 4 plus 2. So iron is here plus 2. So K4 efficiency, we are getting iron in plus 2 oxidation state. So first one is plus 3 and second one is plus 2. Now we have to find out the spin only magnetic moment of this Fe3 plus and Fe2 plus systems. First we will do Fe3 plus. So what is the atomic number of normal iron? That is 26. So 26 means electron configuration argon, 18 electron system, 3d 4s. So 4s2 and 3d, 18 plus 2 20 and 3d 6. Okay, 6 plus 2 8, 8 plus 18 26. Now Fe3 plus means 3 electrons will be removed from the outermost shell. So Ar 3d 5, because 4s2, 2 electrons will be removed from 4s and 1 electron will be removed from 3d. So 3d 5. So Fe3 plus is basically 3d 5. So you are getting 1, 2, 3, 4, 5. 5 unpaired electrons. Okay, 5 unpaired electrons. Now you find out the mu value. Mu equal to root over of n into n plus 2 Bohr magneton. So root over of 5 into 5 plus 2 Bohr magneton. Root over of 35 Bohr magneton. So almost 36. 36 is 6 into 6, 36. So 6 Bohr magneton. But we can write 5.92 or 5.9 Bohr magneton here. Okay. This is the approx value actually. root over of 35. Now we will see about the Fe2 plus system. So Fe2 plus becomes, from here you can find out Fe2 plus electronic configuration, that is Ar 3d 6, because 2 electron will be removed from 3d, sorry, outermost orbital, that is 4s. Okay, now you draw the d orbital, 5 d orbital first. 1, 2, 3, 4, 5, 6. So 4 unpaired electrons, not 6. Okay, because on is paired up. On orbital is paired up. So 4 unpaired electrons. Now you find out the mu value. Mu equal to root over of n into n plus 2. So root over of 4 into 4 plus 2 Bohr magneton. So almost root over of 24 magneton. So 24 means almost 5 Bohr magneton, but you have to write 4.92 because it is 24. Now you see the options. So first one we are getting 5.92 and second one we are getting 4.92. Now see the options, 5.92 and 4.90. So this is the value, approximate value. Okay, 5.92 and 4.90. So this is the correct answer. Okay, so thank you. We'll come soon. Second part of the spin only magnetic moment questions, because there are different types of spin only magnetic moment questions which already came in previous years. So please do like, subscribe, and comments, and please subscribe. If you subscribe this channel, you will get all the notifications, all the important topics which will be discussed about the JEE Mains level and advanced and NEET level exams. Okay, so thank you so much. Thank you. Please subscribe my channel.